The problem is to analyze the function f of x equals negative 2x squared plus 4x minus 1. As x approaches positive or negative infinity, the term with the highest power of x dominates the behavior of the function. Since negative 2x squared dominates and negative 2 is less than 0, the function approaches negative infinity as x approaches positive or negative infinity. To find the zeros of the function, we solve the equation negative 2x squared plus 4x minus 1 equals 0. We use the quadratic formula x equals negative b plus or minus the square root of b squared minus 4c all divided by 2a, where a equals negative 2, b equals 4, and c equals negative 1. Substituting the values, x equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 2 times negative 1 all divided by 2 times negative 2. Simplifying inside the square root, x equals negative 4 plus or minus the square root of 16 minus 8 all divided by negative 4. This simplifies to x equals negative 4 plus or minus the square root of 8 all divided by negative 4. The square root of 8 can be rewritten as the square root of 4 times 2, which equals 2 times the square root of 2. Substituting back, x equals negative 4 plus or minus 2 times the square root of 2 all divided by negative 4. Separating the fraction, x equals negative 4 divided by negative 4 plus or minus 2 times the square root of 2 divided by negative 4. This simplifies to x equals 1 minus or plus the square root of 2 divided by 2. Therefore, the zeros of the function are x equals 1 plus the square root of 2 divided by 2, and x equals 1 minus the square root of 2 divided by 2. First, the axis and the downward opening parabola are drawn. Because the negative quadratic term dominates, both ends fall without bound. The curve crosses the x-axis at its two zeros. Solving the quadratic formula simplifies the square root of 8 to 2 root 2. The two exact zeros are 1 plus or minus root 2 over 2.